So once again, good afternoon and welcome to this WorldCereal webinar on phase 2 of the project. Today, we're going to give you some information on what to expect and how you can contribute to this new phase of WorldCereal. We'll have some speakers coming up. We'll first have Zoltán Santoy, the ESA technical officer from WorldCereal, who will give us an ESA perspective on WorldCereal and especially also the incentives behind the phase 2 of this project. Afterwards, me, Christophe van 't Richt, will give you some more information on the project phase 2 as the project lead of this new phase. Afterwards, Hendrik Bogaert from the Wageningen Environmental Research will tell us a bit more on the continued efforts of collecting and harmonizing in situ reference data and how you can contribute in our efforts there. And finally, Jeroen Degeriks from Vito will tell more about user engagement and capacity building throughout this new phase of the WorldCereal project. We'll end with Q&A sessions, so please feel free whenever you have a question to let us know through the chat. This webinar will also be recorded and be shared on our WorldCereal website afterwards for you to consult. So with that, I would like to give the floor to Zoltán to open this webinar with an ESA perspective on WorldCereal.
Thanks a lot, Christophe. Hello, everyone. So my name is Zoltán Santoy. I'm a land application scientist at the European Space Agency. This is within the Earth Observation Directorate. So I'm actually based in Frascati, which is next to Rome in Italy. Next slide. Yeah, so before jumping into the WorldCereal per se, I wanted to put up this slide just for you to see the past, the current, and the future fleet what we have. And of course, not only fleet of satellites, but data as well. You see the dates. We are not looking very much back, but from 2010. And of course, we have kind of the categorization of science, Copernicus, and meteorological data, or sensors, or satellites, if you will. From here, we will be focusing on the Copernicus, mainly on the Copernicus fleet, and even within Copernicus, some of the radar and optical missions, which are currently flying, Sentinel-1 and Sentinel-2, and some of them will be coming up, Sentinel-1 and Sentinel-2 continuation, plus some others, which I will mention at the end of my talk. Thank you. So, how we work or what we do. So, as I said, I am in the Earth Observation Directorate, but I work in an application section where what we try to do with my colleagues, each of my colleagues have their own domain. So my domain is agriculture. So within my domain, but again, each of my colleagues will try to pick proper scientifically proven data sets, software packages, programs, you name it, which we think can be placed into a real-world application. And that's what you see here. Basically, we work with different intergovernmental agencies. I can mention FAO, I can mention GeoGLAM, European Commission, among others. But I also work with national governments, see their needs and try to make them happy. So the WorldCereal was conceived basically during interactions with FAO, WFP, and GeoGLAM, where they expressed the interest of, like, hey, you guys have already very good satellites up there and flying, providing really good data. And we think that the data what is coming down can be used for global crop and crop type mapping. So that's how we started. And then, of course, we put out a tender call and going through a tendering process, and eventually someone will win that tender and will implement the project as such. So that's where we are here. So based on all those inputs, and based on a project winner, which was Vito, and not only Vito, is a consortium, we started to work on WorldCereal. That was back in 2019, 2020, it was coinciding with the COVID, but eventually we came through and launched, started the process, and I will show a little bit about phase one through the next slides. So basically, the project was really looked at from a global food security perspective, where of course we have major challenges. Population growth as number one, climate change as number two, but unfortunately, while we were doing the project, conflicts came up as a topic as well, and you all know that what happened with food prices, for example, or in fact just knowing where and what is growing to make sure that everyone on earth has proper food and enough food to eat. So that's how we looked at phase one, or well, that time wasn't phase one, that time was just the WorldCereal project. Next slide. And within that, we had the three aims, what you see here, basically to answer where is the food crop production taking place in Earth, which crop is grown, when and where, and which fields are on top of all these, which we also try to look at the irrigation. So which fields are being irrigated and when. So these were the three main objectives or research questions at this stage. And I think we already put a product there, so I kind of have an answer in front of you. So here we have looked at it, the scientific and technical feasibility, and of course using the before mentioned satellites, mainly Sentinel-1 and Sentinel-2, a little bit of Landsat as well. The main point was here not only to answer those questions, but develop everything in a free and open perspective. So using free data, generate a system which will be also free. And here when I'm talking about a WorldCereal project, or eventual output of the project wasn't necessarily a global crop or crop type map, but actually was a system or aim to see a system in what we can develop in the future, which can be given to any of the organizations or anyone basically who want to work with it. Next slide, please. So we put this video together with Vito just to see what happened during the phase one. So Vito and the consortium partners looked at what is feasible, what can be done in terms of crop and crop type mapping globally, but also looked at the technical feasibility, not from the data standpoint, but also from the building standpoint. Can you build a system which can do this work or this mapping work for the agencies we were working with? Next slide. You already seen through the video some products. Just to mention the global products, what the system, what we have currently can provide. So we have a temporary crop extent, we have a seasonal active cropland, we have a seasonal crop type, and we have seasonal irrigation outputs. Now here, temporary crop extent, global product, where is crop? Seasonal active cropland, again, global level. And the key, of course, here is the activity. So we don't necessarily say, or the system output would not necessarily say what is growing, but it will say is something is growing, and if we think it is a crop. Next one, the crop type, is a little bit even more interesting. Of course, it involved a little more work as well. Here we again have a global product or the system which can provide it, but in fact we are talking about a crop type. So at the first part of the project, or phase one, was basically we looked at wheat, well, we call it cereal, it was a wheat, barley, and rye plus together, and maize separately. So the system is capable to give you production areas, seasonally divided, so it can be a spring season, can be a fall season, can be as the season dictates, different parts of the earth of these crops. And then we generated a very really research-oriented product, a global irrigation map at 10 meters. None of these products were done, as far as I know, at the global level at 10 meters. but especially the irrigation was really not done even at I think a regional level. So that was a very experimental product, but we provide that as well, or the system can generate that as well. Next slide, please. So I had to be very brief. So I am already closing phase one. I can say that through phase one, as you can see, we built a system which is up and running, and we have those products coming from the system. So we have not only the system, but the outputs, basically proof of the concept that we can build a system more or less an operational system, and the system can give proper quality outputs. I didn't talk about accuracy and all those. I don't know if the colleagues will mention those, but I can say the products are really good, but I'm not saying numbers here. Now, so we did the phase one scientific and technical feasibility study. We were all happy, not only ESA and the consortium, but the colleagues from the intergovernmental organizations or some of the national organizations we work with. We're very happy with well, I guess we can call it a beta version of the system. Plus, they were very happy with the outputs, the products. So based on that, ESA decided to continue this work, continue in a way of increasing the number of crops we can work with, but also fully stabilizing and making the system available to anyone, basically, being through an online platform, being as a standalone, but you will hear more about that later. Plus, put a lot of emphasis on not only on community building, but training as well. So whoever is interested in the system, how to use it, how to run it, what is needed, this will be all taken care of during this process. As icing on the cake, of course, the increased number of crops. I think some of them are here, but you can see, for example, sunflower will be mapped globally, and the system will be ready to map it anytime, basically. And banana, currently not, although it will be a generic crop type mapping tool, free and open source, so you can plug in your banana model if you want. But also there is canola rapeseed, which will be included among others. Next slide, please. So what we are looking at, what kind of potential applications you have. So you can, once the system is fully out there, you can run it, but you don't have to run it globally, of course. You can run it at the country level, you can run it at the region level. And we hope to tune the system that not only the global products are really excellent, but when you go into your area, not necessarily, of course, at the plot level, but when you go into a country level, regional level area, you will also have very good quality outputs. So building on the products and the system, we envisioning the potential future applications such as crop yield estimation, dynamic area changes, climate smart agriculture usage, and some damage assessment. And the next slide and the last one, as I didn't have much time to spend, just to be pulling up these new sensors, which ESA will be sending up. And of course, for us, the LSTM, CHIME, ROSEL missions could be really useful for not only for agricultural monitoring in general, but of course for these projects in the future. And I stop here, not to take too much of everyone's time. Thank you very much, and really looking forward to phase two, as we call it.
Thank you, Zoltan. That was very enlightening and really necessary, I think, as an introduction here. I would like to give just a little bit more detail on the outcome of WorldCereal Phase I, which ran from 2020 till 2023. So we didn't speak about that in detail yet, but the seasonal nature of the WorldCereal system was really key. There is no just calendar year in which crops are growing. Crops just follow both the farmers and the climatology, meteorology of a region. And especially if you move towards the equator, then things can get really complicated. For example, here in Uganda, corn mapping can really get complicated, and there is no just one corn map for the entire year. No, you really need to take into account seasonality of crops. That's why in phase one, we put a lot of effort into getting global crop calendars, pixel-based, that was describing the winter season where winter cereals are growing and up to 2 maize seasons. This was also published as a peer-reviewed paper, which you can find through the QR code. This was really a cornerstone work throughout the project. And from those pixel-based calendars, we then created agroecological zoning maps, which were grouping together regions of similar crop calendars. And these agroecological zones were then the basic processing units for which we created the WorldCereal products. So although the WorldCereal products from phase one are global in nature, they are actually seasonally describing each individual agroecological zone, mapping crops in their respective growing season. Where can you find these phase one products? Through the viewer, which you can find through the link which is shown on your screen. There you can really also see what the seasonal nature of these products means. You can also find the original products uploaded on Zenodo. They are also ingested on Google Earth Engine if you want to use them there. And they are also available as collections through the OpenEO platform, also on CDSE, so that you can also work with them in your preferred cloud processing infrastructure. Just as a very small reminder that we didn't just produce products, but also worked on a system, and we demonstrated the flexibility of that system by activating it for Ukraine, where we were mapping more than the 2 crops of interest in the main contract. We were adding rapeseed and sunflower there as well. And we were able to produce a crop type map for 2022 without adding any 2022 specific crop type label. So everything was learned already from the previous years. We produced maps for 4 years in a row. And this was for us already a good indication that the system was actually starting to produce what it was aiming to produce. So now into WorldCereal Phase II, which kicked off in December 2023 and runs till the end of 2026. So phase one really was a scientific and technical feasibility study, while now in phase two, we go into operations. We really want to offer a flexible crop mapping service that also gets onboarded and used by the scientific community. So the aim is to refactor the quite complicated system that we have now into a user-friendly and cloud-based processing system powered by OpenEO and running on the Copernicus data space ecosystem by default. We'll be adding a new set of global products for in total 11 crop types. The year still to be decided. Maize, winter cereals, and spring cereals was already there. We'll be adding sunflower, rapeseed, millet, sorghum, and where possible, do a split of the cereals into wheat, barley, and rye, and we'll also be looking at soybean. The system will also support custom crop type model training and application so that you can really produce your custom tailored crop type map, and an addition of a crop yield module as a demonstration will also be added here. We focus really on capacity building now. So we want that the system gets adopted. We want people to use the reference data module about which Hendrik will tell us more in a few minutes. So the cloud-based crop mapping system is really going to be something that is using OpenEO as a processing system, a unified standardized way to work with different cloud backends. CDSE, the Copernicus data space ecosystem, will be the default cloud provider. And so we will really be able to offer this as a service that easily allows a user to just apply and run a model. It has a high performance and scalable processing. And it will be onboarded also in the ESA network of resources so that any user or institute can apply for funding. And once agreed by ESA, there will be some processing costs that are covered so that you can produce your own crop type maps. OpenEO takes care of everything in the backend, data loading of the collections, pre-processing, feature extraction, finally model inference, and you just get the WorldCereal product out there. So, things that in the background still are going to be improved, though we focus on operationalizing, we still want to learn from the past. So one thing that we want to do is revise the crop calendars. So we had really a focus of these crop calendars on the cereals and maize, but we now need to support many more crop types. So the crop calendars are currently being revised into 2 dominant crop growing seasons worldwide, and every crop type will be mapped into one of these, one or more of these seasons. So these seasons will become a bit more broader so that they can also cover multiple crop types. And also the AAZ concept will be redefined, and we will now start from administrative boundaries and not just looking at crop calendars, so that we will also create more intuitive product boundaries that are more in line with what a user would expect. The classification approach itself is also being thoroughly revised. Up till now, we had an expert feature extraction step that from the EO time series and auxiliary data was extracting temporal feature descriptions that were being fed into a pixel-based cat boost model. These expert features, while they are very powerful, are nowadays being surpassed by a more automated feature extraction method. And for this, we are joining forces with our colleagues from NASA Harvest, who developed a lightweight pre-trained transformers model, which does a feature extraction and is trained in a self-supervised learning framework. So they have a pre-trained model trained on many tens of millions of data points for which no crop labels were needed, but we harness that power that helps us isolating the signal from the noise in satellite data. Presto is being adapted to WorldCereal so that we can support the WorldCereal use case, and will be the new default feature extraction method that allows us to extract the relevant information from EO time series and auxiliary data, which will then be fed to still the pixel-based cat boost model, which then finally produces the crop type map. It will still be a hierarchical classification approach. We first map cultivated land, so crops, and within the crops, we'll have a multi-class crop type map within the cropland that will tell us which crops are growing where. Using the new processing system, users will be able to either generate default WorldCereal products, so we will still generate global layers once again for a new year, but the system will also allow you to generate the default products using the default seasonality and models that we trained for a custom year and AOI. That will allow you to make change maps, but you can also combine public and your own private reference data to train custom models, define your own custom growing seasons and any crop type not by default covered by the system, and apply these models to any year and any AOI so that it can actually just cover the use case that you need. This is why we are also interested, now that you know that, to hear about your opinion on how you would be inclined to adopt the WorldCereal system. There's multiple choices here, so please feel free to check whatever you want. So would you want to use this renewed system to visualize and download parts of the global products as produced by the project? Would you want to apply the default models to your region of interest or years not covered by the available products, knowing that for this, no additional training data would be required because our models already have that knowledge? Or would you want to train and apply custom algorithms to maintain full flexibility, which does, however, require you to add your own training data? Or do you not? Don't you have at the moment any incentive to use such a system? We see that half of you has already participated. We are also very happy to see that a really, really small minority has no incentive to use the system, which is good. And for the rest, it seems that we have basically a tie between almost all the three options. So that seems that whatever functionality of these functionalities that we want to offer, that all of them seem to be relevant, which is good. All right. So we have the viewer at the moment, which allows you to explore the WorldCereal Phase I products, but we also plan to add user interfaces to run custom jobs. So downloading the products through the viewer, but also to train your custom model and to generate either a default or a custom product is a planned upgrade of this viewing system, which will really be the centralized place where you can interact with the WorldCereal system. So what are the most important aspects regarding a crop type mapping system affecting your decision on whether or not to start using it? So if we have a system that allows to do this, creating your crop map products, then what is for you the most important thing? You can again take multiple options that would make you decide whether or not to use it. Do you require high map accuracy of the default products? Do you require an extensive reference data availability within the system itself so that you don't need to add your own training data? Is the user-friendly interface key for you? Do you need proper and extensive documentation? Is customizability a requirement to train and apply your own algorithms? Is it in the end the processing cost that will be crucial for you? A seamless integration with other tools? And if so, then we'd like to hear which kind of other tools that you would be interested in. And if there is anything else that you would like to see as an argument whether or not to use a crop mapping system, then also please let us know in the chat. We see that a high map accuracy of the default products is the most important for you. And the low processing cost is not much behind. So this is also why the system that we are now refactoring WorldCereal into is also putting a lot of emphasis on that, because we indeed also find that the processing cost can really be an additional burden to produce your products. And the customizability to train and apply your own algorithms comes in third. So again, these three things are high on our agenda as well. So this is pretty much in line. Okay, so that brings me to the end of my part. Just to give you a bit of a planning on this phase 2 of WorldCereal. So we have in December 23, we had the kickoff. By September this year, we will release a first version of the system, which will at least allow you to do already some inference of the default WorldCereal product algorithms of phase 1 in the completely renewed system. Then in January 25, we'll have a system V2 ready, which will allow also some custom training of the WorldCereal algorithms already. And then in October 25, we aim to start the global production with the final system, which are going to be released in May 26, and then in December 26 will be the project end. Throughout this whole period, we will have many capacity building activities, demonstrations, outreach, and trainings, but Jeroen will tell you a bit more on that later. That's it for the general overview. And now I'll give the floor to Hendrik, who will tell a bit more about the in situ reference data in WorldCereal.
Thanks, Christoph. And hi, everybody. Yeah, reference data. Reference data is really essential to train these crop type identification algorithms. So, but how do we define reference data in WorldCereal? So there are three main aspects. First of all, of course, you need to observe what's there. So it's which land cover, which crop type label. And we would like to see that as detailed as possible. For instance, if it could be winter durum wheat, that would be perfect, but otherwise wheat or even cereals. But and the location is another main aspect, and it could be polygons or points, preferably in the center of the field. And it should be also pretty precise, like an accuracy of 10 meters or less. And the last aspect is the date. We would like to have the precise date so that we can accurately map the feature data to the observation, to the label data. And the observation should relate to a field that has some certain minimum aspects, like you can see here on the slide. This type of reference data we have collected in phase 1. So we did a data discovery. So we, through a structured survey, through our network, through web search, we discovered many different sources. Then we decided which sources would be helpful for us. And those we have downloaded and harmonized, standardized. Then we also looked at the data in more detail, looking at the background, studying the data, and make an assessment how useful they are for our training and also to share it with the public. So the data fitness for reuse, completing the metadata, looking at the quality of the reference data. And the data that is public and could be shared, we have then made available through the portal. Next slide. So I want to zoom in on two aspects here. First of all, the harmonization. Well, so one main aspect is that we converted the original labels of crop type into the WorldCereal legend, so that we are clear about the observation if it is maize. And we also apply a hierarchical legend. So, for instance, if we would have winter durum wheat, then that could also be used to train an algorithm on wheat or on cereals, but preferably as detailed as possible. The other thing we looked at and we developed in phase one was a scheme to assess the fitness of the reference data. So looking at the quality of the data through 3 different dimensions. So, for instance, the dimensions are space, temporal, and thematic. And for instance, in terms of spatial accuracy, we look, for instance, if the observation was overlaying with roads. And to a certain extent, then we can clean the data, but we also took samples and then looked at the sample and checked if they had a good position in the field and not very close to a border, for instance. And another example, temporal, preferably the date, but if it's a year and a season, then it's less precise and we give a penalty for the score. So we lower the confidence score. So a perfect score would be 100, but for these 3 different dimensions, we looked at the data and then we, if needed, we lowered the score if it was not optimal. And then the data that has been, this harmonized, standardized data has been stored in a repository. We call it the reference data module, the RDM. And that can be, the data can be visualized. So here you see an example of a map with different data sets that have been harmonized. You see an example of the metadata that is stored according to stock format. And you can also access this through this link and barcode. This is then the result of the phase one, and you see that we have quite a lot of data in certain continents, like in Europe and North America, but also some in Africa. But we also see that we have big spatial gaps. And that is a concern. So sufficient public, preferably public, so that we can share with the community. Sufficient reference data and the quality is a concern, and we have seen in the production of these maps that the quantity and the quality really matters. And if that is not good enough, then we also have lower quality of those products. So reference data is important, and we're looking for more data. So if you have or you know about reference data that can be shared with WorldCereal or with preferably also with the whole community, then yeah, we need you, and we would like to that you contact us and drop a message, and you could do that through our portal, through the contact page. We also ourselves are active, and also in phase 2 we will do campaigns, for instance, through the regional use cases, mobile phone campaigns to collect more data, and also other innovative approaches where we use, for instance, street view imagery, and use AI to select the promising pictures and then also recognize the crop through AI. And as Christoph explained, you could also, you're invited to use the system and use your own data. So you can use your own private data, combine it with the public data to train custom models. And this data, we make it as easy as possible to upload this data into the WorldCereal system. So here you see an example where you have, for instance, a shapefile and user data set, and we make it as easy as possible to upload that to our system and harmonize it. So we only ask for a few questions, and then our procedure is doing the harmonization. And also, to a certain extent, do the mapping to the WorldCereal legend. Of course, we ask the owner to review that mapping to be sure that we don't introduce any error in. And then this data can be used in the system to train algorithms. It's stored in a private part, so nobody else can use it. It's only you. But we would like to stimulate and that people also share it with the community. So, and if you want to share it with the public, it's in another repository, in a public repository. We will do an additional review, looking at the background, making full metadata, and also doing this quality control, like I explained, for the 3 different dimensions. So here's another poll that we invite you to answer. So this is about the incentives for sharing reference data. So what would most motivate you to contribute your own data to the system? And you have multiple choices. So it could be improvement of the overall quality of WorldCereal products, specifically in your region, or the ability to create your own custom models using your own data, like I explained. Additional quality control that we offer you if you upload your data set. We will, with the WorldCereal moderator, we will check your data and together with you, improve the data. You'll be recognized and appreciated for your contributions in the publications that WorldCereal will create. You could have access to the system to a certain extent for free with credits, but it's limited. You could, also think that, it's your value, it's your motivation to be transparent and collaborate in agricultural, and it's aligned with your values. You could collaborate with experts and peers. That could be in motivation, or others that you can specify it. And maybe you're not allowed to share your data. So please fill in this doodle, and then we will have a look. It's not me that can see the results, so I will ask one of my colleagues to share the results and briefly discuss those.
It seems that collaboration opportunities with experts and peers in the agricultural industry is coming in as the top incentive, closely followed though by the access to free processing credits. So if you get free processing credits in return for adding reference data, that seems to be an important incentive. And then we also have the improvement of the overall quality of the WorldCereal products and the ability to create your own custom models, which seem to be important as well. That are the most important ones that are popping up right now. Thank you.
Okay, thanks, Christoph. Then my last slide is about, we're very much concerned about this reference data, and it's really needed to improve the products. And so we're also collaborating with the GEOS, the Group of Earth Preservation, and we are strengthening the in situ data in this GEOS platform and Geo portal. Wrong one. So in a separate project, it's called the GPB project, also through ESA, concerning WorldCereal, we are looking for a long-term host of this RDM, this repository of reference data. There are different options that we are exploring, but also making sure that the RDM, so the repository, is accessible through the Geo portal. And we're also registering the RDM and in the end also the WorldCereal system in the Geo Knowledge Hub as a package. So also active in strengthening in situ data in the GEOS platform and inviting others to also contribute there. And you're also invited to, if you're not have done yet, that you could also fill in this survey on in situ data. And with this last slide, I would like to thank you for your attention. I give the floor back to Christoph.
Thank you, Hendrik. And I'll pass it along right away to Jeroen to tell us about the last part of this webinar on user engagement and capacity building.
Thanks, Christoph. Like Christoph already introduced, in this last part of the webinar, I want to highlight how you as an interested user in the WorldCereal project can more closely engage with us, aside from contributing reference data, that is, as explained by Hendrik already. So our goal throughout the project duration. We actually want to demonstrate the capabilities of the system and encourage you as a user to start adopting the system for agricultural monitoring purposes. And we have 3 types of activities that actually support this overall goal. So we are planning to do some regional use cases throughout the project, also engage in food security scenario analysis, tell you more about that later, and then also many capacity building activities, of which this webinar is actually one. Let me quickly zoom in on these regional use cases. So we are now in the process of defining use cases on 3 different continents with the organizations that you see mentioned on the slide. We are still setting up these, but the overall goal of these is to really demonstrate to the broad user community how you can, first of all, produce local WorldCereal products and how these products can then be used for further downstream applications. And for instance, in Brazil, we are exploring the possibility to use custom WorldCereal products in order to improve local yield estimations of winter wheat. And that is just one example. In Africa, we'll most likely focus more on smallholder farming systems. And then in India, because it covers such a big gradient of environmental conditions, we want to highlight the benefit of in situ data and local in situ data to improve the WorldCereal products. A second type of activity is then this food security scenario analysis. So we will be activated, actually, or requested by ESA to generate local WorldCereal products to support impact assessment in the face of natural disasters, or even, and hopefully not, but human conflicts. If you as a user have a certain food security crisis in mind that you would like to see covered by the project, you can always get in touch with us, and then we can discuss with ESA whether we want to support your specific case through the project, yes or no. And then finally, the capacity building activities. So we will be offering different types of training activities to serve really a diverse audience. The idea, you see the different types of activities listed here on the slide. So the idea is, from the bottom up, we will really start with very generic information on the project and its progress and the major outcomes. And as we move up in the slide, we move to very technical, detailed training events where we will actually teach you how to operate the system and how to integrate the system for your own agricultural monitoring activities. So quickly going through these different types of trainings. As I said, promotional packages, we will produce some videos, generic posters on what the major outcomes of the project will be. We will be hosting 6 webinars in total throughout the project, of which this is the first official one. And that will be more, again, generic updates on how we progress within the project, what are the main outcomes. Then we'll have 3 dedicated and extensive online courses hosted on our WorldCereal website, freely available to anyone, covering more in detail the technical concepts or the theoretical concepts behind crop type mapping, including also some exercises for you to learn how to work with the system. And as you see on the slide, we already have 3 topics in mind to cover in these online courses, being reference data and model training for the first one, the actual use of the WorldCereal system, and then how to use it for downstream applications. We will release 1 online course every year of the project. Then these face-to-face trainings, they will be hosted, 3 of them, 3 on different continents, and they will be in close collaboration with these regional use cases I was showing earlier on the slide. So there you will have the chance to really engage with us face-to-face, and we will tackle how to use the WorldCereal system for a specific use case. And then lastly, if you as a user are interested to really implement the system on your premises or actively start using it, you can always request a technical training, which we will also be organizing throughout the project. And then as a last poll question for you, we would actually like to know from your side which specific topics you would be most interested to learn more about in these specific trainings. So is that either collection and harmonization of in situ reference data, more background on how we deal with crop type classification, the workflows and the algorithms behind it? Do you want to know more about the global crop calendar, so the crop seasonality, about our validation activities, on how to derive crop statistics from these crop type maps that we produce, how to use the crop type maps for downstream applications, how to operate the system from a technical point of view to generate maps for your area of interest? Is that more on how we as a more from a technical point of view, how we succeed in producing these types of products at global scale at 10-meter resolution? I mean, that requires quite some optimization and IT related optimization. Do you want to know more about that? Or if any other topic you have in mind, please specify in the chat, and then we will do our utmost best to cover those topics in the upcoming training events. I see that more than half of you have by now already answered. We will give a bit more time because there are many options there. I see for the moment that obviously the crop type classification, workflow and algorithms is of high interest, but also how to then actually use the system to generate your own maps and how we perform validation of the crop type maps. So these three topics are, I would say, the most popular at the moment. Crop statistics also obviously very important for policy monitoring, etc. Okay, thank you very much for your replies. This is very useful information for us to shape our future training events. I think with that, I would like to proceed to one more slide on how to stay updated on all these upcoming activities. So obviously you find all the information on our WorldCereal website. You can also use this QR code to directly subscribe to our mailing list. Then you'll be automatically informed about upcoming training events. You can follow us on the different social media channels. And I want to highlight that we will be present at 3 conferences in the next few months. So in May, we have the Year for Agriculture Under Pressure, the ESA conference. We also have the Geosymposium in September in China and the Open Earth Monitor Global Workshop in Vienna. And then our next webinar on the first version of the system will take place in fall this year. So stay tuned for that. And also our first online course will be launched later this year. And with that, I would like to thank you for your attention and invite you to post your questions in the Q&A section so we can dive into a more interactive part of the webinar.
Thank you, Jeroen. Indeed, feel free to add any questions that you might still have after this this brief but broad explanation on what our plans are in the Q&A. There have been some questions already. We wrote down here a couple so that we can already tackle these. There was a question on the Ukraine system that we briefly showed a result of on whether that was based on field boundary delineation. I have to say that the whole WorldCereal system works pixel-based, although at the end we do a little bit of a spatial cleaning with a sieving operation. So no, what you see there is the result of a pixel-based operation and not a initial field segmentation. Of course, Ukrainian fields are quite large and quite homogeneous, so this obviously helps with getting this clean result. But it's a pixel-based crop map and not a field boundary-based one. Then we got probably from a poll the suggestion on a seamless integration of the system into other things, such as weather information, drought information, and so on. This, of course, is also on top of our minds in the design. So WorldCereal refactored system will be very modular. as implemented on OpenEO, which is a standardized API, it will allow the data that we produce to be available as collections almost anywhere on any cloud instance where you want to interact it with. So whatever ancillary data set that you want to have seamlessly integrated should by design be possible. Then we also had a question on the reference data, which was actually being used for the global and actually then also the local products that build up the global product. We do have that information. So for each AEZ-based product, we do know what model was triggered to create that product. And for each model, we know exactly what reference data has been used, which data points were set apart for independent test sets, and which data has actually been used, and from which original reference data set it has come to train those models. So that information is there, and we also intend to keep that in the refactored system, because with the heterogeneity of all the individual data set that are being harmonized into the reference data module, we also think that full traceability of how these data sets have been used to train the models is key. Then there was a question on CatBoost, why we chose for CatBoost. We did, in the start of phase I, a lot of benchmarking. We didn't officially publish that, but there was quite some investigation on what model was actually returning the best results. In our experience, in the end, your feature extractor is the most important thing. So if you have good features that describe differences between crop types, the downstream classification model itself does not matter that much. Therefore, we went downstream for a classification model that is state-of-the-art, but also lightweight enough so that it can run without very heavy compute-intense requirements, no use for any GPU. And CatBoost can also be easily retrained, which is why for us it was really important to go for an algorithm that can support custom model training without the need for some very heavy GPU model training. Then there was a question on that we support area estimation, but what about crop yields? And I don't know, maybe Zoltan, you want to just give a little bit more insight into why yield estimation was added for phase II, and also to what extent, because if I'm correct, we don't have the aim at the moment to produce global yield forecasts, right?
Very interesting and, of course, timely question. Well, I would like to state that we think that we reached a certain maturity in terms of crop in general and crop type mapping at a global level and at 10 meters. Now, but I also want to state that I don't think with yield estimation we are there yet, actually not even close, I believe. So what ESO asked from the consortium is to look into a potential yield estimation, look at the potential models. Of course, we want to still stay within the free and open realm, and just give us an idea if this is feasible at a global, regional, or country level with one system, such as the WorldCereal system. And of course, not only that you run a model, we want to see some real results in terms of knowing how accurate the model, how accurate predictions the model can give, how fast the model can work, what the model needs, so all that behind. So if you remember, I mentioned in phase I, we looked at the potential of irrigation mapping as a little bit of as a side project, and here in phase II, we do the same with the yield estimation. So it's a little bit of a side project, of course, all together with WorldCereal, but still yet a little bit of an outside project, which we will develop or use a model, whatever we decided to, and we will have a certain product out, and we will see if we can put, or we shall put more effort in that area, not within this project per se, but perhaps in another call another research project. I hope I answered the question. I don't know if Vito has anything to add.
No, I think that's it. I mean, it's gonna be a challenge, and it's for sure not something that will be by default anything that runs globally, but it's high on the agenda everywhere, and we also want to demonstrate it as an additional modular capability of the system, where the yield is an obvious though challenging one. But really, the proof here needs to be that WorldCereal doesn't stop with crop type mapping. All the downstream applications that are using crop type maps, they should in the end also be possible to seamlessly integrate them with this kind of system. Continuing some of the questions here, Mario suggests from FAO to help refinement of the crop calendars. Any help there is greatly appreciated. We start already from existing crop calendars, the most recognized ones, and we try to harmonize and extrapolate and interpolate as much as possible. But obviously, some local expert knowledge to give us feedback, especially now in this stage where we are refining them, is much appreciated and can only help in reducing the errors that we make in some local regions. So definitely, please reach out to us, and we will do the same for feedback on the newest crop calendars. Regarding the fee or financial contribution to be part of this project or to have access to the platform, the renewed platform is still being set up. So that first version of the renewed system is only due in the fall of this year. By design, it will by default run on the Copernicus Data Space ecosystem. The nice thing about that is that as a newly registered user on CDSE, you will always get some free processing credits anyway. And also in collaboration with Cloudferro, we are aiming to have some additional free credits available for people that want to early test the system. So we will definitely inform you on the plan for that, and as soon as we are looking for people that want to test, and especially if you want to test the functionality to train on your own training data, that is something that we will heavily support. We got a second question also, again, on the benchmarking on whether or not we tried time series related features in crop type mapping. Well, by the very design, our inputs to the crop type map models are time series related. So we use a full growing season of satellite data and meteorological information that goes into the feature extractor. In phase one, we had our expert features such as medians, percentiles, and so on that was describing those time series, which then were fed into the model. Now this is being taken care of by the Presto feature extractor, which describes all these different kinds of time series related inputs into 128 embeddings that fully describe the growing season in this case, and then the downstream cat boost model finally makes the prediction. I see that there was also a question on how many crop types that were used in initial model training. Jeroen, you want to have a little bit of information on that one?
No, well, basically, I just already answered the question through the chat. So basically, we used all the crop types that are represented in the data sets that we were able to gather in phase one. So whenever a data set contains 50 crop types, we just use all the data we can to train our global models. So it really depends on what's available and what is shared with us. Yeah, and that's all. If you want to explore the reference data that we used, you can obviously go to our reference data module website to browse through our data sets.
As we are running out of time, I'll just take the last two questions that I see popping up here. An interesting one, once again, on the algorithms themselves. There are indeed huge amounts of deep learning approaches coming in for crop type mapping. Now, the Presto feature extractor, we didn't go into much detail, but this is in fact a pixel-based foundation model. It has its own downstream task that you can train for crop type, but we decided to take it apart and just use it as a foundational model as feature extractor and train our own CatBoost model on top of that, just to allow, again, to easily retrain it for user-specific products. So we have to balance on a very thin line between state of the art, which is moving very rapidly, but also keeping operationalization in mind. So this is why we chose the approach that was working now the best. And of course, it's impossible to keep up to date with every new model that is appearing. But we believe that with the current design choices, we are quite future-proof. And then finally, Fred, WRI is very excited. That's good to hear. So indeed, we also hope with all the big institutes to collaborate as much as possible and to keep being fully in line with also the user requirements. Because we don't want in phase 2 to be a technology push and just to develop a system that in the end nobody will use. So whatever kind of request that you might have or that might help your work, we are always eager to find out and to take that up into the further design and refinement of the system. If there's any questions that haven't been answered so far, please feel free to reach out if it's a burning question. The presentation, we should check if we can share them like this, but the recording will anyway be available on the website, so you can always see the entire slide with our comments on top of that. So that will be circulated shortly once that recording is ready. Remains just to thank all the other speakers here, and especially also you for being here with us today and for really engaging with us. Please stay informed through all our channels. We like really to be continue to build a WorldCereal community, not for the sake of the project, but really to, as a community, be able to push the boundaries of crop mapping. So with that, I thank you all, and till very soon.